In this video, we're going to talk about Boyles Law. Now, Boyles Law is a correlation between pressure and volume and pressure and volume. So P1V1 equals P2V2. And so basically we have our initial pressure, our initial volume is going to be set to be our initial final pressure and final volume, assuming this is a closed system. And so anytime you have questions like this, you typically need to consider the closed system and also consider some values that you know, such as certain standards. And so one of the other things we want to consider, so for example, STP, we might have 101.3 kPa, we might have 1 atmosphere, 1 ATM, we might have 760 torr. And so those are some of the consistent values that you should be familiar with that relate. Now, on the New York State reference table, they provide you with 101.3 kPa, and 1 atmosphere as standard pressures under the standard temperature and pressure units. That's what STP stands for. And so when we see our units, we really have 1, 2, we have 3, 4 things we're going to solve for. And when we get in a question, typically that question is going to have 3 of the values. So if we look at this first question, a sample of 100 milliliters of oxygen has a pressure of 10.50 kPa. If the pressure is changed to 9.91, what is the new volume of the gas? So I have 3 values. I have a pressure value there, a pressure value there, and a pressure value here. So we just need to substitute. And a lot of times New York State just says show the correct substitution or show the correct setup. And so if we look at this, a sample is 100 milliliters and a pressure of 10.5. If the pressure is changed, what is the new volume? So we're trying to solve the new volume is going to be my V2. So when we set it up, my first pressure and my first volume are these top 2 numbers, but we got to make sure we're using the right one. ml, of course, is a volume, but kPa is a pressure. So my first pressure, 10.50 kPa, and I'm going to multiply that by 100 milliliters. That's my first volume. And I know that the pressure is changed to 9.91 kPa, and I want to know what V2 is. And so just like a mathematical expression where we have, something we're trying to solve on one side, we need to get rid of the other piece. And so what I'm going to do, I'm actually going to divide both sides, we can't see the line there, but I'm going to divide both sides by 9.91 kPa, and I'm going to divide this side by 9.91 kPa. And so my kPa units cancel out, and I'm going to have 10.50 times 100 divided by 9.91. And what we get after we do that math, V2 is going to equal 105.95, or if we want to go with and round it up, we could say 106. And so those units, because I started with a milliliter unit and I only have milliliters left over, I'm going to have milliliters as my final answer. So depending on which one you're using, if you're looking for significant figures or not, we could say 106, because when we do calculations with significant figures, this one has 4 significant figures, but this one has 4 as well, but then this one has 3. So my final answer should really only have 3 significant figures if we want to do that based on the rules with going with the one with the least amount of significant figures. Again, our formula P1V1 equals P2V2. We'll do another couple examples here, and hopefully you will understand the concept and it will start to make sense. A flask containing 95 centimeters cubed is a volume, of hydrogen was collected under a pressure of 731 millimeters of mercury. Now, I said that 760 torr is another standard. This one is giving you 731. It says, at what pressure would the volume be 70 centimeters cubed? So again, I have 3 numbers. I have my 95 centimeters cubed, 731 millimeters of mercury, and 70 centimeters cubed. So I have 2 volumes. I want to know at what pressure. So I'm solving for P2 in this case. So if we first go 731 millimeters of Hg, Hg is the symbol for mercury, and that's 95 centimeters cubed to start. That's my volume. I want to know what P2 is. At what pressure? Okay, we're trying to solve P2. Would the volume be 70.0 centimeters cubed? And I could add my 0.0 in there. Sorry, I forgot to left that out. It's not going to affect the math just make sure it's 95.0, not 950. So just like we did on the top, I want to get rid of something on this side, so my thing, or the thing that I'm going to solve for, pressure, is by itself. So I got to divide both sides by 70 centimeters cubed. And the centimeters cubed cancel out in this case. So now, again, we have 731 times 95 divided by 70. And so when we do our math, my P2 is equal to 992 millimeters of Hg. Now, one of the things we want to look at, I want to go back and we'll look and compare both of our answers. Pressure volume and pressure volume, they're what's known as an indirect proportion or an indirect relationship. That means if one goes up, the other goes down. So if we look at our first example, pressure was at 10 and went down to 9.9, or 10.5 went down to 9.5. So if pressure goes down from one scenario to the next, then my volume should go up. 100 went up to 106. Now this was not a big jump. 10.5 to 9.9 is not a major decrease, so 100 up to 106 should not be a major decrease. But if we look at this example, we started out with 95 and we went down to 70. So if volume goes down, then the opposite should happen with pressure. If volume goes down, pressure should go up. And so volume went down from 95 to 70. My pressure went up from 731 up to 992. So that was a little more significant of a value. Okay, this went down quite a bit in volume, and that one went up quite a bit in pressure. And that whole proportion brings us to this next section here. We don't always need to do a calculation if you can do this in your head just by thinking of that proportion. Again, if one goes up, the other one has the exact opposite. So for example, if I double my pressure, then what happens is my volume gets cut in half. It's the reciprocal or the inverse. If I triple my pressure, the volume is going to be 1/3 of that. If I take my pressure and multiply it by 10, okay, if I 10x my pressure, then my volume is going to be 1/10. And the same would hold true the other way around. I could have said if I 10 times my volume, then my pressure would be multiplied by 1/10, or if I, doubled my pressure, my volume is cut in half. Okay, so for example, if I have a volume, notice we're starting with volume of 50. If I have a volume of 50 meters cubed, okay, gas has a volume of 50, I want to know what new volume is going to happen if we change the pressure. So based on these scenarios here, if I double my pressure, so if we double the pressure, I really cut the volume in half. So 50 gets cut in half. Half of 50 is 25 meters cubed. If I cut the pressure in half, though, if I do the opposite, okay, this is kind of the opposite. If I cut one in half, the other gets doubled. And so if I cut the pressure in half, that means I'm going to double my volume. So if I started with 50, I'm now going to be doubling 50 to 100 meters cubed. If I triple my pressure, okay, triple my pressure, that means I cut in third my volume. So 50 divided by 3, I take a third of 50. 50 divided by 3 is 16.7 meters cubed. Okay, so I hope you found some benefit and you're starting to understand what is going on here. We're going to do one more because it shows the other value that's associated on the reference table with atmospheres, and that's question number 5. I'm going to skip number 4 for right now. But question number 5, if the pressure of a gas is 3 atmospheres and the volume of the gas doubles, what is the new pressure, or what will the new pressure of the gas become? Now, we only see one number here, but this is very similar to this process here. I don't necessarily always have to use P1V1 equals P2V2 if I understand the concept that if one goes up, the other goes down, basically a reverse amount or a reciprocal amount or an inverse amount. So if I know the gas has a pressure of 3 and the volume doubles, so if the volume doubles, then pressure gets cut in half. Remember, they're going to do the opposite. So if volume is times 2, then pressure is basically 1/2 of that. We're going to take the inverse or the reciprocal of 2. So half of 2 would be 1.5 atmospheres. So there you have it. That is a couple of examples of Boyles Law. Again, Boyles Law is an indirect or inverse relationship, and it is one of the parts that makes up the combined gas law between Charles' Law, Gay-Lussac's Law, and Boyles Law, where we have all of pressure, volume, and temperature combined together. All right, this has been Mr. Gardner with chemistry, and hopefully you found some benefit. Take some serious action. Make sure you practice your questions, and if you have any, be sure to ask them below. Take care.